So today we're going to talk about domain and range. So pause the video for a second, make sure you write down these two definitions, they're really important, and then when you're ready, press play. So for the domain of a function, it's the set of all the input values or x values. So when we think of solutions to an equation or a function, there can be x, y points like this. So the domain is all of the x values, like that first coordinate of any point. And then the range of a function is the set of all of the output values or the y values. So the x values tell us the domain, the y values tell us the range. First thing we're really going to get into is identifying domain and range from these three different types of, problems. So the first one is from a table. So you could see the table split up into x on the left and y on the right. So for me, I think this is the easiest way to identify domain and range. Obviously not every problem will be like this, but it's pretty straightforward because the points are already organized for you. So when you're asked to identify domain and range from a table, the domain is just going to be a list of all of the x coordinates, and the range will be a list of all of the y coordinates. The only thing is you want to make sure that they're in order from smallest to largest. These ones look like they already are in order, so that's nice, but in the future just make sure that they're not in order, that you do order them. So when you go to write domain, you write it as a set. So you open this set with kind of like a silly looking parentheses. It's like a squiggly parentheses like this. And then we just order the numbers from smallest to largest. So our smallest domain value or x value is 0. Our next one is 1, 2, 4, 5. So just listing the x values. If there's one that happens more than once, you don't have to list it more than once. You only have to list it one time. So if 0 was right here and right here, you would not have to list 0 more than once. And then for range, same thing. You're just going to make a list of all of the y values. So we open it with that same kind of squiggly parentheses. And we want to go from smallest to largest, so 1, 4, 7, 13, 16. And close with that squiggly parentheses. So pretty straightforward when it comes from a table. Now we'll move on to when we're pulling domain or range from a list of points. So if we want to make a list of the domain from a set of points, we have to know that domain is associated with the x coordinate and range is associated with the y coordinate. So if I write a point, it goes in this order. So that means that all of my first numbers are all of my x values, and all of my second numbers are all of my y values. So if I want to list my domain, I have to find the smallest x value first. So there's 5, 7, 2, -2, and -3. So -3 is my smallest. If you want, you can cross it out so you don't count it twice. -2 is my next smallest. 5 is my next smallest. And then 7 is my largest. And then we'll do the same thing for for range. We just need to make a list of all of the y coordinates. The y coordinates are the second one in each point. So my smallest y coordinate is, there's a 1, a 3, a -9, and a 1. So 9 is my smallest. And then it looks like my next smallest is 1. But there's another one over here. You don't need to write it twice. You can just write it once. And then we can move on to 3. So 3 is my largest range value. And then if we move on to identifying domain and range from a graph, it works in a very similar way as a list of points. So if you don't already have each point labeled, like if you were just given the dots, I would go ahead and label them because I genuinely think it makes it easier to just list it out. It's taking that little bit of time to label them. Remember, with points, you go left to right first, and that's your x coordinate. So if I want to figure out what this point is, I'm going right to 1, 2, so my x coordinate is 2, and I didn't go up or down at all, so that's why the y coordinate is 0. for this point, I went 1, 2, 3 right, so my x-coordinate would be 3, and then 1, 2, 3, 4 up, so my y-coordinate would be 4. For this point, I'm going left 1, 2, 3, 4, so my x-coordinate is negative 4 because left is the negative direction for x, and then I'm going down 2, so y is negative 2 because I'm going down 2 instead of up 2. Whenever you're ready to list your domain, it starts the same way. Oops. And we're going to list off the x-coordinates from least to greatest. So to avoid you having to jump all the way around trying to figure out which one's the smallest, you can figure out the smallest x-coordinate to greatest pretty easily just by going from left to right across the graph. So if I start on my leftmost point, and I'm just looking at the x-coordinates right now, just the first number, the point the furthest left is negative 4. And then the next leftmost point is negative 3, 4, so my x-coordinate is negative 3. And then the next one over is 0, negative 3, so my x-coordinate is 0. The next one over is 2, 0, so my x-coordinate is 2. Again, still just looking at the x-coordinates only for domain. My next one over is 3, 4, so my x-coordinate is 3. And my next one over is 5, negative 4, so my x-coordinate is 5. And then for range, we're going to do the same thing. We're just going to be looking at the y-coordinates now, and instead of going from left to right to get the smallest to largest, we're going to start from the bottom up to get the smallest first. So my lowest point is 5, negative 4. So negative 4 is my y-coordinate. That's what my range will start with, is y-coordinate. The next one up is 0, negative 3. So negative 3 is my y-coordinate. The next one up is 4, negative 2. So negative 2 is my next y-coordinate. The next one up is 2, 0. So 0 is my y-coordinate. And then it looks like the next two are at the same exact height. They both have a y-coordinate of 4, so that's my next range value. So my domain is negative 4, negative 3, 0, 2, 3, 5, and my range is negative 4, negative 3, negative 2, 0, and 4. So next type of problem that we're going to talk about is determining if a relation is a function. And we're going to focus on when it's in two different forms. So the first one is when it's in a table. And this goes back to something that we talked about in a previous lesson. This little note that says each input can only have one output, but two different inputs can have the same output. So this is how we determine if something actually is what we call a function. So when we're looking at its function or a relation in a table, and we want to determine if it is a function or not, we have to make sure that each input has exactly one output. So we'll go through each table. So for the first table, I have an input of negative 1 and an output of 5, an input of 0, an output of 3, and an input of 1, an output of 4, an input of 2, and an output of 7, an input of 3, and an output of 4. And this is okay. So right now, I'm just making sure if each input has exactly one output. So right now I have 1, 2, 3, 4, 5 different inputs, and they each only have one output. So this is a function. One more time, the reason that we can say it's a function is because I don't see the same input up here twice. So if I say this was not a negative one, but a positive one, then one would have an output of 5, and one would also have an output of 4, but we're supposed to make sure that each input has exactly one output. If it went to 5 and 1 to 4, then it would have two different outputs, 4 and 5. It's okay that two different inputs have the same output. That was kind of like the birthday function that I've talked about before. This is like saying that two different people have the same birthday, and that's fine. But one person can't have two different birthdays. So yes, this is a function. If we look at the second table, we have an input of 3, an output of 0. We have an input of 4, an output of 7, an input of 5, an output of 10, an input of 4, an output of 14, and an input of 10 and an output of 25. So this one is not a function because the input 4 has two different output values. There's one where it goes to 7 and there's one where it goes to 14. So that same input of 4 has not exactly one output, it has two different outputs. So it's not a function. So it is a function if every input just only has one output. It is not a function if an input has multiple different outputs. The last thing we're going to do is decide if something is a function based off a graph. So when it's a graph, we use something called either the vertical line test or the pencil test. And that means we need to drag a vertical pencil across the graph. If it intersects at more than one point at once, it's not a function. So I'm going to actually use a ruler because it's a little bit thinner. So if I drag my ruler vertically across the graph, it doesn't intersect at more than one point at any one time. It always only intersects at one point. So this is a function. For the second graph, I'm going to do the same thing. I'm going to drag my ruler across my graph vertically. So if I drag it across, it's only intersecting with one point at a time. So it's intersecting like right here. Now it's intersecting right here. It's only intersecting at one point at once. So yes, this is also a function. And then for the last one, if I drag my ruler across this graph, right away it's intersecting with more than one point at once. It's intersecting at the bottom of the circle and at the top of the circle. And it's okay, even though if I keep going all the way across, it's going to continue intersecting at more than one point. If at any point on the entire graph it crosses through at 2 or more, then it's no longer a function. So this one is not a function because it crosses through at 2 points at the same exact time, up here and down here. So the last one is not a function.